Hey friends, today's video is going to be focused more if you're currently a service technician and some tips and things that you can do to save you some time when you're out in the field. Okay, so tip number one has to do with wiring capacitors in parallel. What is that and why would we even need to do that in the first place? Well, to give you an example, let's say you have a indoor motor here, right? This is a permanent split capacitor motor. And we know that because it has a cap. And let's say it has a 15 microfarad capacitor. So let's say I don't have a 15 microfarad capacitor. I only have a 10 and a 5. Instead of traveling an hour to the supply store and getting the 15, of course, if it's just down the street, then that would make sense. Just get 15, go down the street, get the right microfarad capacitor for this. But let's say it's far, right? In that case, what you can do is with the 10 and the 5 capacitors, microfarad capacitors that you do have in stock, it can give you 15. And the same would apply for the compressor side of things, the Herm. If you have a 50 with two 25s, it can give you 50 microfarad capacitor. So how do we do it? How do we get 15 microfarad capacitor with two capacitors, one being 10 and one being 5? Well, let's find out. So I'm going to go back over here and let's say to show you, right? So on the other permanent split capacitor motor where I showed you right now, you had two brown wires. So just imagine these red wires are my brown wires, okay? I'm just going to try to simulate the same example. So let's say this capacitor was going to my permanent split capacitor with my two brown wires. I got rid of the 15 and I put a 10 right now. So I got my 10 right here, right? 10. And this is 5. Okay, so I need 15. All we're doing, super simple, guys. When doing capacitors, wiring them up in parallel, you're going one side here and then going on this side. And it doesn't matter if it's over here or over there. It's not reverse polarity sensitive. You just go on one side like that. Okay, that's done. And on this side, we'll go on the side that you didn't grab initially, on the other side right here. And like I said, it doesn't matter if I switch this over here, right? It's not reverse polarity sensitive. You just make sure that it has to go from one side to one side and then the other one to the other side. So let's go ahead and put it on microfarads. Okay. All right. So just so you know, just to confirm, right? I'm just going to take it out just so you know that I'm getting true readings. You see, that one should give me 10, 9.98. This one should give me 5, okay? When I add them together, right, because we're doing parallel, let me go ahead and put it here. 10 plus 5 equals 15. Let's go ahead and find out. There we go, 15. So there we go. We got our 15 microfarad capacitor. And have in mind, don't use jumper cables for the jumpers here. You would have to create your own jumper cables like these with the female connectors like that. You want to use jumper cables because they cannot handle enough current. And if you wanted to, you can still add more capacitors in parallel. So this is also a 5. So I put one right here on this side and go on this side. And then on this side, so 10 plus 5 plus 5, that should give me 20, right? So let's go ahead and check it. So all I did is wire everything in parallel, right? It's kind of like jumping, boom, boom. So check over here. You see, I got 20. And I can keep doing that, right? But typically you do this when you don't have that right one, but you have two that add up to that. All you would have to do is just wire it up in parallel, like you see here. I'm gonna go ahead and show you again so you can see it. Just wire it up in parallel. They also have this thing where you can wire it up in series. So we have, and I don't think I've seen anyone do this, but if you have, let's say you need a 30 microfarad capacitor and you only have like an 80 and a 50, and there's actually a formula for that. If you run it in series by using those two, and of course they would have to be the right microfarad numbers according to the formula. If you have two big ones, it can give you a smaller size.
but I hardly have seen that example out there. The one that I've seen has been this one, wiring up capacitors in parallel. If you don't have that one, you can just take two that add up to that one that you need, and you can get the job going.
Okay, so this is the other tip. For example, this is a dual capacitor, right? So we have what is the C, the Herm, and the fan over here for the condenser fan. Let's say the 5 microfarad for the condenser fan does not work. It's giving me 0. The Herm still works, right? This is a 35 microfarad. So when you check C and Herm, it gives you 35. But when you check C and F, it gives me 0. So how can we tie in another capacitor? Because let's say we don't have a dual cap. We only have another 5. How can we now include this one so that it works with this capacitor, so that when I call for cooling, my compressor and my condenser fan turns on? Now, of course, this is not where you would place the capacitor, although I have seen the capacitors being placed here for years, and it tends to work, but you want to strap it here, right? But I'm just showing you the example here so you can just see it. All you would do, because we just said the fan on this capacitor is not working, you would go ahead and take this one, right? Because this is for my start winding for my condenser fan. It doesn't matter if it goes here or on that side. Go ahead and put this side, right? I'm just going to put on that side. This is what's important. A lot of guys get confused right here. This one needs power. All you're doing though, you're going on that side and you're going to your C right here. That is my power. So I'm going to go ahead and put it there. So the one that I took out from here, I go ahead and put it for the condenser fan. I put it on that side, and it doesn't matter if it's on this side and the red one's on that side. It doesn't matter. But I went on this side. This one here, the red one, goes right there. I put it where the C, right? Because that's my power coming here. So you see that one is gone. I'm not using that anymore because it gave me a 0 microfarad, but the Herm is still good. And I don't want to get another dual cap. I just have a single cap, and this is how you would do it. You would get the condenser fan, put on that side, and you have to make your own cable. On this side, get power, and like this, that would work. That would get your compressor and your condenser fan to turn on, but you need to create this jumper so that power can go also on this side so it can turn on the condenser fan. Okay, so here's another tip. How do you check the capacitor with voltage or power on? Because as you know, you can check it by turning off power, taking a picture, especially if you're starting out on the trade, remove the wires and check it with microfarads, right? And this one specifically is 35 and 5 plus or minus 5%. So you do the calculation and it should be under that range. But how do you do it with power on? So there is a calculation here with power on. Microfarad equals amps times 2652 divided by volts. So this specific microfarad for the Herm is 35 microfarads, and the compressor is on. Obviously, the compressor has to be on. So 35 microfarads. So when I do the calculation, it should be close to 35 or under that range that the capacitor asks for. But let's go ahead and do the math. It says amps and volts, so we need to get these numbers first. The way you do it is go ahead and get your meter, put it on amps, which is right there, AAC, amps, you see, amps up here. You're gonna grab the wire where you have the Herm coming out, that wire going to the start winding, but where the Herm is at, which is my blue one, Herm. And be careful not to touch that, right? That will shock you. So I'm gonna go ahead and get the amps for the blue wire, and I'm gonna do my best to maybe get it here. So let's see if I can get it back here. Okay. All right, so I am getting 3.66, okay? 3.66, you saw that on the meter. So 3.66, so 3.66 times 2652 divided by volts. So what is volts? So for the volts, all we're doing is putting it on volts, right? We got to put this on volts. So it's already ready here, down here. And one lead goes to my C, right? One lead goes to my C, right? Which is this one here. And then the other one goes to the Herm. And it's going to give me a voltage. So
let me see if I can do this without getting heard. And so you guys can see also in the meter. So one's gonna go on Herm, one's gonna go on C. Let me see if I can do it where you guys can see that one and that one. Okay, I am getting, and you can see it right there on my meter, 272. 272. Okay, I'm getting 272. So nice. Now I got my numbers. 272. Now I am using my phone for this, and I cannot figure that out in my head. I have to use my phone. So you know what? I can actually ask Siri on my phone. So let me go ahead and do that. Hey Siri, what's 3.66 times 2652 divided by 272? Let's see what it gives us. There we go, 35.685. 35.685 microfarad. Okay, so are we in range? Yep, it's a good cap. So that's how you would do it. If maybe you cannot disconnect the capacitor, or you cannot turn off the unit, it needs to be on. This is how you would do it. You would have to remember the formula, get the math, right? The amps comes from my blue wire going to my start winding of the compressor. The volts here comes from checking the C and the start winding amps. Those are your volts, and you do the math. And if it's near or close to it, under that range, then you have a good working capacitor. Okay, so tip number one had to do with capacitors. Tip number two is making sure your reversing valve is working right. So it is important to understand how reversing valves work, but if I were to do just a quick class on this, you have 4 lines. You have the line in the back. That's my discharge line. That is my discharge line coming from the compressor. And then the 3 right there, you got 3 lines then right here on this side of the reversing valve. So you always have 4 lines. So in this specific case, let me go ahead and, okay. So you got the line in the back. Right now it's in cooling. So that line in the back, it's traveling and going on this side right now. So that temperature over there and this temperature right here on this line, they should be roughly the same. You should see maybe some manuals will tell you 6 to 8 degree temperature difference at the most. So if you check that temperature right there and this temperature and it's more than 10 or even 20, there's something going on with the slider inside. You might have to replace the reversing valve. But right now in cooling, that line in the back, 1 line, and then this one should be pretty much the same. And then these 2 on the right, it's coming like this. It's going up and making a U and going on my suction line. That should be pretty much the same. So all we're going to do is check if it's working. So I'm going to go ahead and put the clamp, and you got to be careful, right? Because you got a condenser fan right there. So that line in the back, there is a discharge line. It's coming from the discharge line. So you can see it, right? This is my discharge line going to my reversing valve. So I'm going to go ahead and put that there. Okay, good. So let's see what temperature it gives me. Okay, so wait a couple seconds. And let's see what temperature it gives me. It should be close to, I think, 100. I thought I saw 122 earlier. Maybe 123. We'll give it a second or two. We do want to be patient, right? If you're out in the field, you want to just make sure that's the right, close to that number where it kind of stops. So let's say 125. Yeah. If it drops 0.1, I'm just going to leave 125. So it's 126. 126. So I'm going to go ahead and grab the temperature clamp and put it on the line that it's coming out from, which is on this side right now. So let me go ahead and put it on that side right there. Okay, you see, it's on this side because it's coming like this. It should be pretty much the same. So have in mind too, right now it's a little bit difficult because I removed the panel right here. It could be a little bit off. You don't want to have, panels closed, and it's hard because you have to put the panel back, and but I mean, you can only do your best here, right? And now that we've gotten the numbers, you see, it was what, a 126? But right now we're reading 124.9, 125. So you see, we're under that range. If I would have checked that and it was 126, and then maybe it was 116 or 110, that's past a 6 to 8 degree temperature difference. So that's doing its job. Great. So now we're going to check these two lines. These two lines on the right should be pretty much the same. So be careful when you're doing this. Like I said, you have a condenser fan there that shows no mercy. That blade there will cut you. So I'm going to put it on this side and try to get it where you can get a good grab, maybe like vertical, not so much on the corners. Sometimes you just got to do your best. So then, okay, it's right there. And now it's going to drop. It's going to drop. But you guys get the point. I don't think we have to wait too long here. You guys get the point. It should be pretty much the same and temperature difference. So it looks like it's stopping there at 65. It's slowing down. Yeah, 65. I'm going to go ahead and put it on the middle one now. Okay, on the middle one right there, right? It should be pretty much the same. And it's 65. It might be dropping a bit, but at least it is under that 6 to 8 degree temperature difference. Great. So we know that it's working. Right now I have it on cooling. So this system defaults to heating. So you can also do the same test in heating. Of course, if it worked in cooling, I would assume that it might be okay. But honestly, it's always good to do it in heating mode. So right now this reversing valve, if it receives 24 volts, it operates in cooling. If I remove this one wire, right now it's in heating. So now that high pressure, high temperature vapor, now it's coming out on the right side, and then these two share. And you can do the same test as we just did right now. So that would be one way to check if your reversing valve is working okay or not. Okay, so tip number 3 has to do with the contactor. And specifically, I am not referring to the contactor coil, even though it would be nice if the label here tells you what your coil reading should be. Typically, should be between 13 and 21 ohms. But I'm talking about the condition of the bridge right here. A lot of times with your own eyes, you're able to see if it's pitted or not, if it's dark and burned. Think about it. It's going down, up, down, up, down, up. It creates like an arc effect where in time it starts to get pretty black. And so how do you check if this right here, this path is in good condition? Well, whether you're working with this contactor or a 3-pole contactor, it really is simple. So right now, my unit is on, the compressor is on. Right now, as you can see, I don't know if the light's gonna be better or not, probably not. So you can see 0 right now, okay? So I'm gonna just check. So you got incoming power here, right? L1, L2, and L3. And for my load, or going to my system, is T1, T2, T3. So what I'm doing, I'm just gonna check line 1 with T1, because it's just a line. And I'm gonna check it, it should be less than 2 volts. So less than 2 volts, I check it. Okay, you see, it kind of went up to 6 a little bit, and then it went down to 0. So we're good, it's below 2 volts AC. I'm gonna check this one, 0 and 0, right? So that tells me that contactor is in pretty good condition. And I'm gonna go ahead and confirm, of course, be careful here, but look at that contactor, it's practically new. It looks in good condition. Maybe compared to maybe this one here, maybe there's some more discolorization there. It's a little bit black and pitted. This one, you might get that voltage difference of 2, but when you go to a contactor, it could even be a disconnect or even a breaker. It should be 0 because all it is just a path from here to here. If you get that 2 volts AC or greater, there's some form of resistance here. So let's say you have 120 volts coming in, you should get 120 volts coming out. But what if you're getting 120 in and 100 coming out? Something's going on right here that's causing that voltage to drop. You're getting a voltage drop. And typically that's due to resistance, due to not making good contact, pitted contacts, different things. So when you check it, it's just a bridge. Power in, power out, it should be 0, as long as it's under 2 volts AC. And so this is another thing you can do, which is the contactor. Obviously, if you see that it's pitted, visually replace it, especially if it's stuck close. But another way you can do is, as long as you're reading 2 volts AC from line to load, line to load, line to load, then you have a good working contactor. Okay, so the last tip has to do with the method called non-invasive. So let's say you're on a call and your S-mans, your digital gauges fall down and break. So you still have to finish the job. You need to get pressures, get superheat and subcool. What can you do? Well, the non-invasive method allows you to get the temperature of the condensing temperature in this case. Because we can agree that with the gauges, because it's 410A, right? You can see it right there, 410A. Let's see, there we go. 410A, high side pressure is 347. Convert that to condensing temperature is 106. But let's say, like I said, your gauges break. You can't connect your hose to the pressure port to read pressure, which gives you a temperature. So what you can do is get your field piece and then get this clamp right here, and they call it right here, and you can see it. Sometimes they come with it, but it's a type K thermocouple. You can see it right there. Let's see if we could, I want you to get a good idea of that. Type K thermocouple right there. So sometimes they come with the meter. These are nice because it allows you to read temperature. So what you can do is then connect it there, right? It's gonna go there. Okay, cool. Put it, you gotta move it to temperature, right? Fahrenheit. Okay, and what you're gonna do, so this is my condenser coil, right? So it's the superheating, right? It's only vapor form, removing that sensible heat, and then it's saturated, a mix of liquid and vapor, and then it's subcooled liquid here on the bottom. So you want to get a temperature of this part here, the middle of the coil. So what I'm gonna do, I'm gonna go ahead and put it right here, right in the middle, right there. Okay. All right. So we just said, and what I do though, I try my best to put it, I make sure that it's touching the tubing. I know a lot of guys will put tape, but I just push it in right above the tubing so it can kind of like create like a blanket over it. It can grab the surface. And the aluminum fins, because it's tight, it keeps my thermocouple from moving. So it's there. So we just said that my condensing temperature is 106. And let's say I didn't have this, right? But it's just to show you how accurate it can be. 106. What's my temperature? It's 105. So it's about a degree off. It's not too bad. And so what you can do now, you can actually grab subcooling because we already got our condensing temperature. So now it's 105, right? Go ahead and remove this. Grab my temperature clamp. And if you recall, for subcooling, we got to put it on the liquid line, right? So my subcooling for this system, let me go ahead and connect it here. Okay, I'm going to put it on the liquid line. We just said my condensing temperature was 105. So 105, let's give it a second. 105 minus, give it a second, 97. That's 8 degrees subcooling. Okay, it's going to 98. We have about 7 degrees of subcooling. 85 minus 185 condensing temperature minus 98, 7 degrees subcooling. And we didn't use any gauges. You just have to make sure you put it right in the middle of the coil, because this part will typically be a lot hotter because you're superheating that sensible temperature from vapor form. But right in the middle, they'll get your condensing temperature minus your liquid line temperature, right? If you have that temperature clamp with the type K thermocouple, which I just showed you right now, with this and with that, you can do the job of what gauges would do. Of course, gauges they're a lot nicer, more accurate. You are connecting to the pressure port. But the same applies for right here for the evaporator coil. You would obviously have to tape it up right there somewhere in the middle, cover the panel, and then get your suction line temperature, and that would give you superheat. So like that though, doing this, you're able to do it in the non-invasive method or non-invasive invasive form. In case your gauges break, you left them at home, you're able to get them. But obviously, if you have your gauges, use your gauges because they're more accurate. You're reading the actual pressure in the system. But this is another way, another tip in case you don't have your gauges with you. So friends, these are some of the tips that I wanted to share with you. Maybe you have tips of your own that have saved you time and money.
on your calls. We're all in this together. So maybe you have some tips you want to share. Please feel free to share them on the comment section, and maybe others can benefit from it as well. I hope that today's video helped you out, and I will catch you on the next one.